All right, we're real proud of our new CMCP TKPro. It's some people call it a wobulator. Its purpose is to provide a fairly calibrated signal into a eddy probe or proximity probe system to verify your monitoring performance and everything is working correctly. In other words, end-to-end testing. Okay, the way the wobble plate works is we have what we call a wobble plate. This is a spinning disc that we can spin at variable RPM, and it's cut at a slant. So if you're looking at the center of the plate, there is no change. But if you're looking at the edge of the plate, it's going high to low. And that's where the term wobble plate comes from. So if you see when I turn this on, you can actually see the plate wobbling. So if the proximity probe is looking in the center, you have 0 mils vibration. If you're looking at towards the outer edge, you have 15 mils of vibration. So this particular kit will go from 0 to 15 mils of dynamic vibration. And the swing arm is used to adjust where on the wobble plate the eddy probe or dial micrometer are looking. Okay, what we're going to do first is set the swing arm using the dial indicator. And we do that by using the proper collet. Then we mount the dial indicator into the swing arm. Now, we can change the amount of vibration it sees by swinging where the dial indicator sees the wobble plate. So right now I'm getting 11, almost 12 mils of vibration where I'm adjusted at right now. That's a little high for some compressors and stuff. It may be running at 2 or 3 mils. So I'm going to bring it in a little bit. Now we're still a little high. Bring it in a little more. There's 1, 2, 3, 4, 5 mils. Bring it in a little more. Okay, just the 0, 2, 3, 4, 5.5, 5.6 mils is where this is set right now. Okay, what we do then is we make sure that it's tight. We take out the dial indicator. We replace it with an eddy probe. We install the eddy probe. The collet's purpose is to make sure that everything is centered in exactly the same place. Okay, what we're going to do now is gap the probe. We've installed the probe, and it's the same collet we use the dial indicator because the 3/8 24 probe uses the same 0.375 collet. And now we're going to gap the probe to about 10 volts. And we do that by simply screwing it in and out a little bit. So that's fine right there. That's a decent gap. 10.82 volts, as you can see on the voltmeter. Now we're ready to run our test. We can turn the TKPro on, and you can see by looking at the tachometer we can adjust speed to be anything that we want it to be. Speed does not affect displacement. So basically the output of the proximity probe is going to be the same at 1 RPM as it's going to be at 7,000 RPM. But 3,600 RPM is a very common. So we're going to run this at, you notice we have very excellent speed control. So right now it's about 3,600 RPM, and it's producing, it's at 11.52 volts DC minus gap. Okay, the TKPro wobble plate outputs what we call a sinusoidal output because the plate is slanted. The output is going to be very sinusoidal, so some of our basic calculations work. We install this probe, we measured the dial indicator. Using a voltmeter in AC mode, we see our output is 0.599. 0.599, and that's millivolts. All right, now a voltmeter works, first of all, it works in RMS. And it also works what you might consider zero to peak, or zero to peak RMS. So what we have to do with a voltmeter output is we have to take the output we see on the AC reading of the voltmeter, and we have to take the 0.599 and multiply it times 2 to get to peak, and times 1.414 to get from RMS to peak. So we really have 1.694 volts. So right now we're outputting 8, I can divide that by 200. So we've got 8.46 volts outputting right now, or 8.46 mils, excuse me. So with this running, hooked up to your system at the machine, you go back to your monitoring system. The monitoring system should be reading about 8.5 mils. If you happen to have an oscilloscope, we can look at the output, the dynamic output of the signal directly in the oscilloscope from the driver, and you see we set the lines here. We have 1.66 volts on the oscilloscope from the high to the low, and you can see the signals very sinusoidal. So anyway, we're producing 8.5 volts, 8.5 mils going into the monitoring system, and by moving this swing arm, you can see we can do any number we want. So you can produce anything like 1 mil, 2 mils, all the way up to 15 mils as far as sending signal to the monitoring system. You'll notice back on speed, we can adjust the speed that I've had set at approximately 3600. We've got the ability to go up to over 7,000 RPM. And the ability to go low if you're setting up a system for a fan that runs at 200 RPM.
Go ahead.
The TKPro comes with the TKPro itself, which has the lithium-ion battery, the tachometer, everything you need up here, swing arm. This is the key phaser hold down place. If you've got a key phaser in the machine, you can mount a probe in here to get a key phaser pulse. It comes with a stereo dial indicator, plastic feeler gauges, Allen wrench, the selection of 4 collets, a smart charger, which plugs in right here. So you can charge it up at night, and it's a smart charger, so you can let it charge without worrying about it. And there's a green light and a red light on the charger that will tell you when it's charging and when it's charged. Comes in a weatherproof travel case, and if you buy the kit with this CMCP 610 static calibrator, then you get the 610 static calibrator with it for running DC probe curves.